So cardiac muscle is small cells, single or double nucleus. They depend on oxygen. That's why you have an extensive blood supply to the heart. That's why people who get clotting of the blood vessels in the heart can have a big problem. I luckily don't have much of that, but I have some, and my problem was my fluid in my heart. The intercalated disc or gap junctions or electrical synapses, uh, the contraction time is much longer. They contract automatically, and they can't go into tetanus. If your heart goes into tetanus, you have to have a defibrillate it and to stop it from not pumping because your heart has to pump, relax, pump, relax. So if you have a problem with heart arrhythmia where it goes into tachycardia, which greatly increases the frequency of beats, the heart really can't function because it has to have time for the blood to fill the atria and to fill the ventricle and then pump. Then it has to relax and wait for the next load of blood to be put into the atria, then the ventricles and contract. So smooth muscle, non-striated, doesn't have any cross links. It's involuntary. Motor neurons are often unneeded. So this is slightly different from how calcium is used in striated muscle. But in your blood vessels, in your gut, in your bladder, these automatically contracting short muscle fibers that don't have cross striations, so they have no sarcomeres. So they're involuntary. They're under local nerve control or hormonal influence. They have pace setter cells, and they often don't need motor neurons. So cardiac muscle has the intercalated disc, and it has, notice, the striations, which are the little lines that go across the long axis of the muscle. Cardiac muscle is branched, usually uninucleate, and the purpose of these intercalated discs is to allow the impulse to move very quickly throughout the muscle fibers so that you can have coordinated beating of the heart, where first of all the atria contract and then the ventricles, and the ventricles actually wring out the blood. So these electrical synapses, called gap junctions, are allow for very rapid, coordinated, multi-fiber contraction in the heart. Smooth muscle. This is a cross section, transverse section, a longitudinal section, and you can see that each cell is uninucleate and just a little, called a fusiform shape. It means it has a thick middle and points at either end, and the smooth muscle is developed in your embryo as large numbers of smooth muscle growing together to move food in your gut, move waste out of your gut, control blood vessels, control your bladder, and they're arranged in different directions, like you're looking here at a cross section through these fibers. So depending upon what type of movement you need in your gut, for instance, the arrangement of these many smooth muscle, their direction and how they're arranged with respect to the movement that is expected. So you can have different mixing movements and propulsive movements in the gut based upon the different smooth muscle layers. Okay, so take a good look at this table to see what the differences are. I don't ask many questions on this, but there may be a few. Okay, now we got to learn the muscles. Okay, so you should know the name. You should know the name of all these muscles. And WebAssign will have uh, exercises where we identify. We spend a lot of time in the thigh, some in the upper arm, but most of the questions in WebAssign is going to involve muscles in the thigh. Okay. So let's stop there for today. I'll lecture some more on Wednesday and finish this up. So let's stop recording. Stop recording.